All right, today, 5.6. This section is called the Fundamental Theorem of Algebra. This is the foundation of what this topic is all about. Fundamentals, yes. Fundamental Theorem of Algebra is a way to find all, and I mean all, both rational, irrational, imaginary, all roots of a polynomial. All right? So we are taking these big, huge, beautiful polynomials, and we're going to find all of their solutions. Okay. So here's what I'd like us to do. We're going to start with step 1. Find all possible rational roots. That is what we did on that worksheet 1 through 4, right? Step 2. Of the possible, you must find, find, I can't spell, find n minus 2 zeros, where n is your highest exponent. All right, so if your exponent is 5, you've got to find 3 zeros out of your possible. If your exponent is 6, you've got to find 4. Okay? All right, step 3. We are going to use synthetic division to reduce the polynomial to a quadratic. Yeah, so we're going to reduce it down to a quadratic. That's why it's n minus 2. We're leaving it with 2 exponents left, or an exponent of 2, so that we can do it by quadratic, by the square root method, by factoring, by whatever method we want once we get down to that. Okay? All right. Then, step 4. Solve the remaining quadratic, again, by whatever method you choose. And then step 5, list all zeros / roots / solutions, because those all mean the same thing, of the polynomial. So when we get down to this last step, we should have a total of n solutions, right? N is your highest exponent, so we should have n solutions when we're done, okay? All right. So here is example number 1. We are going to go through these steps. And let's start off with find all zeros of f of x equals x to the 4th plus x to the 3rd minus 7x squared minus 9x minus 18. All right. Step one is to list all possible roots. That's what we did yesterday and the day before, right? We take all factors of 18. So 1, 2, 3, 6, 9, and 18. And we divide by all the factors of the first number, which are 1, right? So our possible are plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6, plus and minus 9, and plus and minus 18. Those are our possible. Now our highest exponent is a 4, which means before we can get started, we have to do 4 minus 2. We must find 2 solutions. Or 2 that come out to be zeros. Okay? Now, we can either take all these and plug it back into that polynomial, or you can grab that wonderful calculator you have there, graph it, and see where it crosses the x-axis. Find me 2 spots. You can put it in the table and find me 2 spots. We can do it either way. So you guys all check this out and tell me what are our first 2 zeros we're going to use. Push to the right. Try again. Yeah, negative 3 and 3? Yeah. The other place you can also look is if you hit second in graph, it goes to a table. And you can look at the value of x, and next to it in the y column, it would say 0 also. Okay? So, you're right, Irene. The first 2 zeros we have out of our possible are 3 and negative 3. How do you get out of the table? Second and quit. Quit is like right above, I think it's, yeah, okay. All right, so now, next step, we're going to do synthetic division. So we draw our long one-sided tic-tac-toe. Across the top are our coefficients. So we have 1x to the 4th, 1x to the 3rd, negative 7x squared, negative 9x minus 18, right? And we are going to start with 3 for our first 0. So we bring down the 1. 3 times 1 is 3. Add them together. We get 4. 3 times 4 is 12. Add it together, we get 5. Good. 3 times 5 is 15. Add it together, we get 6. And then 3 times 6 is 18, and it should have no remainder. We're going to put an x there. If you got a remainder, that means you got to go back and check your math, right? All right, now we're going to continue and just continue our little graph, but only draw it out to the 6 underneath. Now we're going to put our next 0, continuing our synthetic, going down. So I bring down the 1. Negative 3 times 1 is negative 3. Add them together, I get 1. Negative 3 times 1 is negative 3. Add them together, we get 2. And negative 3 times 2 is negative 6 with no remainder. So the quadratic we have left is 1x squared plus 1x plus 2. Now we have to solve that quadratic. Okay? So we can do it by the quadratic formula, right? And if you look in our synthetic, we actually already have those broken up. This is our A, this is our B, and this is our C, right? All right, so here we go in our quadratic. We have negative b, or in this case, negative 1, plus and minus the square roots of b squared minus 4 times a, which is 1, times c, which is 2, all over 2 times a. All right, underneath that square root, we have 1 minus 8, or negative 7. So what's the only thing that can come out of that beautiful square root? An I, right? If I have a negative 7 under there, we can take out an I. So our quadratic formula gives us negative 1 plus and minus I root 7 all over 2. 1 minus 8 is negative 7 underneath there. Okay? All right, so that's 2 of our solutions. And what were our first 2 solutions? Yeah, plus and minus 3. We have a total of 4 because our highest exponent was 4, right? Okay, give me questions. Give me anything. Something. Nothing. Yes. Right. You have to get 3. If it was x to the 6th, you'd have to find 4. So you can get it all the way down to a quadratic. So like you get 3 and then you keep going to the 6th. Right. Or you can do the extra. Right. If you can factor. Okay? So let's say it was 6 and 4. How would we have found 4? Okay, so the whole idea is if you have x to the 6th to start with, you have to go through all your possible until you find 4 of them. It's got to get down to 2. That's why I said you take your highest exponent minus 2. It tells you how many you have to find before you start synthetic division. Okay? Got to take you down to 2. If it was only a cubic, we'd only have to find 1, right? Okay? So that's the idea. You're trying to break it all the way down. Now, if we wanted to really be ambitious, we could take these 4 zeros, put them in our factors, multiply them all back together, and we go back to where we started. Right? You see where this might be going? Okay. Let's try another one. All right. Example number 2. All right, so let's say we have x to the 5th minus x to the 4th minus 3x to the 3rd plus 3x squared minus 4x and plus 4. All right, so first we have to find all our possible. So that's all the factors of 4, which are 1, 2, and 4, over all the factors of 1. So out of our possible, we have plus and minus 1, 2 over 1 is plus and minus 2, and 4 over 1, plus and minus 4. So now our highest exponent this time is a 5, which means when we're all done, we're going to have 5 solutions, right? But to start, how many do I have to find? 3. Got to find 3 to begin with out of our possible. Okay? So grab your graphing calculator and either go into the table, type it into y equals, either go into the table, find out where your zeros fall, or graph it. Now, if you're going to graph it, you can plug all this right into your y equals and hit graph and see where it crosses the x-axis. -2, 1, and 2? Okay. All right. Did everybody else get the same thing Irene did? Okay, hold on. I'll slow down. So I said, if you go in the table, you'll see it probably quicker. -2, 1, and 2. Correct. Okay, so now that we found those three possible, we start with synthetic division. All right, so I'm going to draw my synthetic here. My coefficients are 1, -1, -3, 3, -4, and 4. And the first zero Irene told us about was -2, so we'll do that one first. Bring down the 1. No, I know. That's just how I wrote them down here. Yeah, you start with whichever one you want. Yeah. So -2 times 1 is -2. Add them together, it's -3. -2 times -3 is +6. Add them together, we get a +3. -2 times 3 is -6. Add them together this time, we get a -3. -2 times -3 is +6. Add them together, we get 2. And -2 times 2 is -4, so we have no remainder. Continuing with our synthetic, but this time only going out to 2. And let's do 1 next, because that's what I wrote down, right? Doing +1. First thing we do is we bring down the 1. 1 times 1 is 1. Add those together, we get -2. 1 times -2 is -2. Add them together, we get 1. 1 times 1 is 1. Add them together, we get a -2. 1 times -2 is -2, and again, when we add them together, there's no remainder. We have one more zero to go. The last zero we had was +2. So we bring down the 1. 2 times 1 is 2. Add them together, we get 0. 2 times 0 is 0. Add it together, we get 1. 2 times 1 is 2. And again, when we add those together, there's no remainder. So that quadratic we have left is 1x squared plus 1. Equal it to 0, and let's solve it. How do we solve x squared plus 1? Yes, the square root method. So that means we're going to do what, Gabe? I need to get x by itself. What am I going to do?
Square everything.
Not quite yet. I got to get x by itself. What should I do first, you guys? Minus the 1 to the other side, right? So I have x squared equals -1. And now to get rid of the squared on the x, we have to square root both sides. And we get x equals plus and minus. What's the square root of -1? I. So we have plus and minus I. We had plus and minus 2. And we had 1. So we have 5 answers. Because the exponent was 5. Right? Yes.
So how do you go from like the synthetic, like the 101x, to get an x squared plus 1? How do you go from that?
This right here, this term is x squared plus 0x plus 1. The coefficients are what we have left. Every time we divide, we just have the coefficients left over.
But wouldn't that have been x5 that went down?
Right. So, okay. So, let's go back for a second. Okay. Let's cover your question. All right. So, at the very beginning, if I can get back to the beginning. All right. Right here, it's x to the 5th. When we divide the first time, it goes to x to the 4th. Okay? Then we divide again, it goes to x to the 3rd. Then we divide again, and it goes to x squared. Okay? Other questions? No? We're doing okay? Yeah. All right, so let's do this. Instead of me giving you even more, this is what I want to try and do. if instead of 9 problems, I give you 5, I need to guarantee that everybody is going to try and do those 5, all 5, all right, before they come in tomorrow. Okay, it's only 5. Actually, let's make it 4. I want all of us to do 4 problems before we come in tomorrow. All right? So it's going to be 8 through 14. So 8, 10, 12, and 14, that's it. Okay? Yep, so instead of 8 to 24, we're going to do 8 to 14, even. All right? Well, this way, there's only 4 problems. Everybody can do 4 problems, right?
8, 10, 12, 14. I had to think about it.
Everybody's going to do it. While you're gone, yes, there's a lot of stuff while you're gone. I posted